Good morning, Year 12 further mathematicians. Just going to go through a question from the second part of the integration test. Question 6, which is a parametric equations question or parametric integration. So you've been given a sketch of the curve, which is a circle, and you've been given, rather than the Cartesian equation, the parametric equation. They haven't given you a specific radius, they're just called the radius r. So this answer is going to be in terms of r rather than a number. And they've given you a parameter which is trapped between 0 and 2 pi. And we have to find the shaded area. So if we were working in Cartesian form, then we would integrate between a and b, that x value and that x value. The curve y with respect to x. But in parametric form, we integrate between c and d, where c and d are the parameters in terms of t. Y d x by dt, that is the formula that you should know. One way to remember that is the dt's cancel and you're left with dx on both sides. Okay, so I'm going to use this one, but the things which are missing, so I could substitute y in, that's already there. Dx by dt, need to work that out, so let's do that quickly. Dx by dt, r is just a number, so what does cos t differentiate to? Minus sine, so that'd be minus r sine t. Okay, now this is where we need to find out these limits in terms of t. So that is the upper limit. Sorry, that's the lower limit, that's the upper limit. Now, based on what the question says, this is about a circle of radius r. So if this is a circle of radius r, then r is that distance there, and minus r would be that distance there. You don't actually need that, by the way, but I thought I'd put them in. So in other words, that there is minus r, and that there is r in the Cartesian equation. X equals r and x equals minus r. So let's see what would happen if we wanted to find the parameters instead. So at these points, you know that y is equal to 0. So y is equal to 0. So get an equation which is r sine t is equal to 0. If you make the trig the subject, divide by r. Remember, r is just a number. The sine t is equal to 0. And then you find some t values. So inverse sine of this gives you 0, pi, 2 pi, and multiples of pi. And we just need the correct one. So which one would be correct? Now, if you put, because we're only expecting 2 of them, but I've got 3 of them. If you worked at the corresponding x value, which is equal to r cos 0, r cos pi, r cos 2 pi, that would be r, that would be minus r, and that would be back to r again. So you could either take this pair or this pair, and that would get I would get the right answer. So I'm going to take the first two, which are these two. So these are my values I'm going to pick. So back to that integral, which I'll call I is equal to integrate t is equal to 0 produced r, which was the upper limit. T is equal to pi produced minus r, which was the lower limit. y is r sine t. dx by dt is times in by minus r sine t with respect to t. It's equal to, between pi and 0, minus r squared sine squared t dt. Now, you can't integrate sine squared directly. You have to write it in terms of the double angle formula cos 2t. When you introduce powers like sine squared, that doesn't work. Multiples, though, are perfectly fine. So sine squared t would be identical to 1 subtract cos 2t over 2. If you substituted that into this, you'd get 1 minus cos 2t over 2 with respect to t. Expand the brackets, minus r squared over 2 plus r squared cos 2t over 2 dt. And finally, you've got something you can integrate. R squared over 2 would integrate to r squared over 2t. Cos integrates to sine, but you've got to divide by another 2. And that's between the limits of 0 and pi. Okay, and if you put 0 into this, you get 0 subtract minus r squared over 2 pi plus r squared sine 2 pi over 4. That entire second thing there is 0, so you're just left with this term, and 0 subtract negative r squared over 2 pi would give you a half pi r squared. Not sure if I got that in, but substituting the limits in, that thing goes to 0. You are just left with this, and 0 subtract negative this simplifies to a half pi r squared, which is what you would expect because that's half a circle. And that's it.